Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as Assistant Professor at Sharad Institute of Technology, College of Engineering at Rao, Ichalkarji, which is at Kolhapur district, Maharashtra. Today we'll see the motion statements in computer-aided path programming. As we previously discussed about introduction about computer-aided path programming and path programming languages, even APT language structures and geometry statements. Now in this video we are going to see the motion statements of computer aided path programming. So let's get started with the motion statements. These are used to describe paths taken by the cutting tool. The syntax of the motion statements is given by a motion command slash descriptive data. For example, go to or GOTO slash P4, or you can say GODLTA slash 1.0 comma 3.0 comma 0.0. The motion commands can be broadly divided into the three groups. We can say that setup commands, point-to-point motion commands, and contouring a motion commands. So we'll see step by step with this motion statements or motion commands. First one, the setup commands. In setup commands, we can say that start point at the beginning of the motion statement, the tool must be given a starting point. This point may be the target point and the location where the operator has positioned the tool at the start of the job. The capital from FROM command is used to establish the starting point of the tool at the start of the job. The syntax is given by FROM from slash TARG, and the TARG is a symbol given to the starting point, or you can say a target point. And another way to make this statement is FROM slash X comma Y comma Z, where X, Y, Z are the coordinates of the target points. And in startup command, next one is cutter. The cutting tool description, that is cutter, and that can be written as or given like this: CUTTER slash dia, or for example you say CUTTER slash 25.0, where it defines as 25.0 mm diameter of milling cutter. The cutter path is offset from the part outline by 1/2 of the diameter. Yes, so in that, next one is a tolerance. We need to set a tolerance as well. So here the tolerance are specified as outside tolerance, that is out tol, OUT-TOL, and insert tolerance, that is in INTOL. Outside tolerance indicates the allowable tolerance between the outer of the curved surface and any straight line segment used to approximate the curve. And the inside tolerance indicates the allowable tolerance between the inside of the curved surface and any straight line segment used to approximate the curve. So now if you see, for example, NTOL, that is 0.005, this is what inside tolerance inside the surface. This is 0.005, so you can written like this: INTOL slash 0.005. And if you write this OUT TOL, outside tolerance slash 0.005, if you want like this, you have to write like this. Now after setup command, we need to set a point to point motion commands. Point to point motion commands. There are only two basic commands. One is GOTO, go to, and second one is GODLTA. This GOTO command is used to move the tool from the current position to the part specified in the statement, and the syntax is given by, you can say that, go to slash point, or for example you can say like this: GOTO slash P7, GOTO slash 2.0 comma 5.0 comma 0.0. In the second statement, the tool has been instructed to go to the location whose coordinates are x equal to 2.0, y equal to 5.0, and z is 0, 0. The GODLTA command, this command specifies the relative motion or movement along the axis specified. The syntax is given by GODLTA slash dx comma dy comma dz. For example, GODLTA slash 1.0 comma 2.0 and comma 0.0. This instructs the tool to move from present position 1 unit in x direction and second unit in y direction, and third unit is in z direction. Now you can say z coordinate remains unchanged, that is, z remains unchanged. Next is contouring motion commands. These are used to specify the continuous path motion involving milling and turning operations to generate a variety of surfaces. The contouring commands are used to continuously control the tools throughout the move. The tool is directed along two intersecting surfaces, as we can see here. The intersecting surfaces are dry surface. This is the surface which guided the side of the tool, side of the tool, and part surface is here. This is the surface on which the bottom of the tool rides. And third is check surface. This is the surface that steps the movement of the tool in its current direction. This is this is the surface that stops the movement of the tool in its current direction. Four modifier words are used to stop the movement of the tool. TO moves the tool into initial contact with check surface. On moves the tool until the tool center is on the check surface, and past moves and past moves the tool just beyond the check's surface, and tanto moves the tool to point of tangency between two surfaces, at least one of which is circular. So now if you see go, this is used to bring the tool from starting point against the drive surface, that is DS, drive surface, that is part surface PS, that is part surface PS, and check surface CS. The generate formula is go slash DO on and past, comma DS, that is dry surface, again TO on past, comma PS, pass, this is part surface, and TO on fast, and tanto, that is what, check surface. In that sense, here countering motion command can give. If you see an example, go TO L1 TO PL1 or TO and L2. The initial drive surface is the line L1. The initial surface is the line L1. The part surface is PL1 and the initial check surface is L2. The effect of the motion modifier word, that TO on past and tanto, or you can say in this figure, right? So when go back comes another instruction, that is go back. It instructs the tool to move back relative to its position, sorry, previous direction of movement. Go back, that is previous direction movement. If you say go back PL5 comma TO comma L1, the tool moves on the drive surface of PL5 until it reaches L1, isn't it? What is it? The tool moves on the drive surface, that point PL5, until it reaches L1. The effects of the motion commands, that is GO UP down, GO down, FO WRD go forward, like this, preceding move, and GO LEFT go left, go right, and this is, you can see here, this kind of command can be used. So now next is post processing commands. Here in post processing command, these functions are used to specify the machine tool functions. The post process commands are the coolant, that is coolant turns on or off, that is coolant comma on slash on, or coolant slash off, and even coolant slash flood, that is, and another is coolant slash mist. Like that we can command. Fed rate, fed, fed rate, or you can say FED RAT, it is used to specify the feed rate in the per minute. That is fed rate slash 100.0, you can say. And end is, it is used to stop the machine at the end of the section of the program. Here machine, it is used to specify the machine tool and to call the post processor for that machine tool. When you say machine slash mill comma 1, the mill identifies the machine tool type and 1 identifies the particular machine and the post processor. And next one is turret. It is used to specify the turret position on the turret lathe or drill, or to call a specific tool from an automatic tool changer. Turret slash T30 to tool changer, isn't it? Next, spindle or spindle SPINDL. It is used to specify the spindle speed in a revolution per minute, and spindle slash 3000, like that. And rewind is, it is used to rewind the control tape to no tape mark, which is generally the start of the tape, that is starting point. This is what the post process commands. If you see another auxiliary commands, these commands are used to prepare the computer for accepting the part program, improve the readability of the part program, and control the output of the computer. So pip CLPRNT, it is used to obtain the computer printout of the cutter location sequence on the CNC type. CNC tape. Next is FINE, FINE. It is used to indicate the end of the computer program. And PART, part number, that is used to start the program to identify the part program. So this is what auxiliary command. And if you go to repetitive programming, the sequence of similar statement which needs to referred more often in part programming are best referred to by a macro. Best referred by a macro statement. This feature is similar to a subroutine in Fortran and other computer programming languages. And this macro subroutine is defined as of symbol of that is equal to, we can say, macro slash parameter definition, and the symbol must be of 6 or fewer characters and at least one of the character must be a letter of the alphabet. And the parameter definition following slash would identify certain variable in subroutines which might change each time the subroutine is called into use. In order to achieve the macro subroutine, the call statement must be used as like call, comma, symbol or parameter specification. The symbol would be the name, that is we can say that we can use as the name of the macro that is to be called, and the parameter specification identifies the particular values of parameters and that are to be used in the execution of macro subroutine. The very last statement is termac. It is what? Termac. The index of macro statement is, we can say, that is name, that is equal to macro, that is parameter, dash dash dash. The last is termac. All statements that enclose between macro statement and the termac statement are to be executed whenever this macro is called by call slash name and parameter, isn't it? So this is what we have saw. uh, this is a motion statement of path programming. So in next video we'll see the APT path programming to cut the profile as particular uh, size. So next video we'll see about APT path programming in a defined geometry. Okay, thank you, one and all.